Hi, everybody. Welcome to hypothesis testing. So let's finish up this. So this is part two of our hypothesis testing. So let's finish up some of these problems. I'm going to do another example where sigma is known. So a car manufacturer has given its van a 43 mile per gallon rating. An independent testing firm has been contracted to test the actual mile per gallon for this van. Since it is believed that the van performed over the manufacturer's MPH rating, mile per hour rating. Okay, so this perform over is going to tells us that this will be a right tail test. All right, a testing of 190 van, they found the mean of an MPG is 43.9. Assume the variance, population variance, known to be 4. So that's a little bit tricky because I need population standard deviation in my computation. So we'll convert it here in a little bit. Is there sufficient evidence at the 0.02 level to support the testing firm's claim? All right. So let's list our population mean. So mu null is going to be 43.6. That's what the manufacturer claims. All right, sigma squared, population variance is 4.41. So if I put that in the calculator and take a square root, then my standard deviation will be 2.1. All right, simple mean is 43.9. All right, simple size, 190. And the level of significance, which is alpha, 0.02. All right. So stated null and alternative hypothesis. So what the manufacturer claiming is the mean is 43.6, but the independent testing firm saying is probably overperformed. So that will be a greater than 43.6. All right. So number 3, we just said that overperform is a right tail test. All right. The computation for the test statistic. So this is Z null equals, right? If I go back, so I'm just gonna substitute my known into this formula. So Z is now equal to X equal to my X bar, my simple mean 43.9 minus 43.6 divided by sigma over square root of 190. All right, let's see what our test statistic is. Let's put that in the calculator. So I want to put the top in the parenthesis. Divided by, I'm going to open the parenthesis for my entire denominator. 2.1 divided by square root of 190. Close parenthesis on the square root, close the parenthesis for the denominator. So my test statistic tell me that it's about 1.97. All right, critical value for the rejection region. So my critical value, zeta alpha, which is 0.02. Since this is a right tail test, let me come down here a little bit. My zeta 0.02, right, is a right tail test. So once I find my critical value, I will know where my test statistic will fall. So 0.02 is the area to the right. So in the calculator, for the inverse norm, we need to type in area to the left. So that will be inverse norm. Area to the left is 0.98, comma 0, comma 1. All right, so it'll be about 2.05. So my critical value is positive 2.05 because and 1.97 is a test statistic, which is fall in here. So this example, we will actually fail to reject. Now, if it fall to inside the right tail, that will be the rejection region. So so anywhere else, we will fail to reject the null hypothesis. All right, so there is not sufficient evidence at 0.02 level to support the testing firm's claim that the vent overperform manufacturer's MPH rating. Okay, so let's do a hypothesis testing where sigma is unknown. So when we do not know our population standard deviation, then we gotta use this one right here. The thing we learned from the t distribution, we need to find this t. We need to use our t value to help us. Okay. So this is gonna be x bar minus the mean of null divided by simple standard deviation over square root of n. So I know I gotta find use the t distribution basically to help us because I do not know my population standard deviation. That's why I gotta use the t distribution. So this example says the director of research and development is testing a new drug. She wants to know if there is evidence at the 0.025 level that the drug stays in the system for more than 345 minutes. For a sample of 13 patients, the average time the drug stayed in the system was 347 minutes, with a standard deviation of 24. So this 24 come from the sample of 13 patients. So that's your simple standard deviation. This is your simple mean. All right. Assume the population distribution is normal. Let's complete the following here. So this is a population mean. The mean of null, they saying is 345. Your simple standard deviation is 24. The simple mean is 347. All right, simple size is only 13. So it's less than 30 simple, but since they told us the population distribution is approximately normal, we can still go forward with this hypothesis testing. And the level of significance alpha is going to be 0.025. All right, so here it says more than 325 minutes. So this is going to be another right tail test. So the null hypothesis is it will stay in the system for 345. This research and the development person is saying it should be more than 345. Okay, so from the sample she took, is there sufficient evidence to support her claim? All right, number 3 is a right-tailed test. All right, the computation. So this is T null, right? Test about T null. X bar minus the mean of null, 345, divided by let me go back and look, make sure I got my formula down pat. S over square root of n divided by S, which is 24, over square root of n, which is 13. Okay, so let's see. Divided by, all right, I'm gonna put the whole entire operation in the parenthesis for the denominator. 24 divided by square root of 13. Close parenthesis for the square root, close parenthesis for the entire denominator. So it's about 0.30. 2 decimal place. So find the critical value for the rejection region. So I need to find the critical value of T. So now we need our formula sheets, because it's a right tail test, right? So it's a T sub alpha 0.025. This is only a one tail test. As a matter of fact, it's a right tail test. So while that thing is opening up, So T's a 0.025 right tail test. Let's see, where's my formula sheet? Oh, forgot to click on it. All right, one tail, 0.025, right? Sample size is 13. So degree of freedom is 12, 2.179. So degree of freedom is n minus 1, which is 13 minus 1, which is 12. So 2.179. So this critical value, 2.179. So test statistic is only 0.30. So that does not fall into the rejection region. So again, this one we will fail to reject. Null hypothesis. So once again, there is not sufficient evidence at a 0.025 level that the drug stayed in the system more than 345 minutes. Okay, so on the homework for the stating conclusion, I need y'all to state, like this. Okay, whether you reject or fail to reject. All right, let's test for population proportion, P. So a sample of 900 computer chips revealed that 58% of chips fail in the first 1,000 hours of use. The company promotion literature actually states that 62% of the chips fail in the first 1,000 hour use. The quality control manager wants to dispute the company's promotional claim. Is there enough evidence at a 0.01 level to dispute the company's claim? Okay, it's dispute. So this problem does not say, it will be more than or less than, overperform, overfill. It just simply says the word dispute. So that right there tells us that this is going to be not equal to. It's simply saying it is not equal to 62%. All right, so your population proportion P sub null, right, they're claiming is at 62%, 0.62. Your simple proportion P hat is gonna be the 58%, 0.58, because that's from the sample of 900. All right, sample size is 900, and the level of significance alpha is at 0.01. Okay, so your null hypothesis, P is equal to 62%. All right. The quality control manager wants to dispute that 62%. So alternative is your P is not equal to 0.62. So that make it not equal to actually make it a two-tailed test. All right, so let's go back and look at this test statistic, the formula for test statistic. So Z sub null again, right? P hat minus P sub null divided by, okay, P sub null times 1 minus P sub null, or Q sub null divided by N. Okay, so P sub null we know is, let me come down here. We know P sub null is 0.62. So Q sub null, right? The population proportion P is 0.62. So the chips that did not fail, the percent of chips that did not fail in the first 1,000 use got to be 0.38. 38% did not fail. So Z sub null equals 0.58, right? P hat minus P sub null 0.62 divided by a big old square root of P sub null times 1 minus P sub null, which is Q. So 100% minus 0.62. is 0.38. So 38% of chip does not fail after 1,000 hour of use. Divided by sample size 900. So then let's see what this test statistic is. So I'm gonna light the top. I'm gonna put the top in the parenthesis. All right, the whole bottom is a square root. I can put a parenthesis or I don't have to. Oops, sorry. So I'm not gonna use an extra parenthesis here because all the operation is together. So if I type in 0.62 times 0.38 divided by 900, that's exactly what I want to calculate to do. Multiply first and divide. So 0.62 times 0.38 and then divided by 900. So the order operation will literally multiply then divide here. Close parenthesis for the square root. Negative 2.47. All right, so we know this is a two-tailed test, right? So if it's a two-tailed test, that would be Z sub alpha over 2. So I know my alpha is 0.01. So Z sub alpha over 2. Okay. That will be 0.01 divided by 2. So it'll be 0.005. So inverse norm. All right, so this is negative Z 0.005. This is positive. Right? One is negative. It's a two-tailed test. One is negative, one is positive. So the area to the left here is 0.005. So when I put my inverse norm here, it's going to give me a negative critical value, which is referring to the one on the left. So 0.005, comma 0, comma 1. So that's negative 2.576, 3 decimal place. So the other critical value is positive 2.576. So my test statistic, negative 2.47. Negative 2.47 got to be a little bit to the right. So you actually fall in here. It does not fall in the critical or rejection region. So again, this example, we will fail to reject. The null hypothesis. So conclusion, there's not sufficient evidence at 0.01 level to dispute the company's claim that 62% of chips fail in the first 1,000 hour use. All right. So the homework, a lot of definition. Question 1, 2, 3, and 4 is all definition. Question number 5, basically the same thing. I think I used 65% this time. My p hat is about 65%. Oh, excuse me. I'm sorry. Number 5 is stating the null and the alternative hypothesis. So make sure you type in H null, okay, and H1, H alternative, right? Make sure you type it out using the graphical equation. 6 and 7 is multiple choice on the definition, type 1, type 2 errors. And question number 8, this is filled in correctly. This is a bagging one. So this one, we do know population standard deviation, okay? And the next one, we do not know the population standard deviation. Okay, so this 14 is based on the 13 bag simple. So that's a simple, okay, standard deviation. So just follow the same steps as I did earlier. Make sure you use graphical equation to enter your answers. Okay, so just using 2 videos to kind of explaining what a hypothesis testing is. Okay, how we actually test whether their claim, okay, the company's claim, the government's claim, whether their number that they're telling us is actually, do we find evidence to support our claim, or we fail to reject what they are saying? Okay, we're not saying by no means we are saying what they're telling us is correct. Okay, that's not what we're saying. It just, we either find the evidence to support our claim, what we think, or we fail, or we do not find enough evidence to support our claim. Therefore, that's why we say we fail to reject what they say. Okay. Alrighty. Thank you so much for watching.